In this video, we're going to focus on writing formulas for ionic compounds. At first, we're going to go over a few basic examples. Then we'll cover examples that contain polyatomic ions and even transition metals. So, before we begin, you need to know the charges of common ions. Elements in the first column of the periodic table, like hydrogen, sodium, potassium, rubidium, even lithium. These metals, they form +1 charges when they become ions. Elements in the second column, like magnesium, calcium, these ions typically form +2 charges. And then to the right you have group 3 elements like aluminum, gallium. In group 3A, these elements form +3 charges. Next to aluminum, you have elements such as carbon, silicon, germanium, but you don't have to worry about the charges for these elements because it can vary. And typically, you won't see them very often in ionic compounds, by themselves at least. Now, the next group you need to know, that's nitrogen, phosphorus. These typically form -3 charges. And then you have elements like oxygen and sulfur, which usually form ions with -2 charges. And then you have the halogens like fluoride, chloride, bromide, and iodide. These ions, they form -1 charges. So make sure you're familiar with the charges of certain elements. Now let's say if we want to write the formula for an ionic compound like sodium chloride. The first thing that you want to do is you want to write the ions that are in this compound. Sodium, we said, has a +1 charge as an ion, and chloride has a -1 charge. If the charges are the same, if they're 1-to-1, you can simply write the ions together. These two ions, they're going to combine into this compound, NaCl. And that's all you got to do to write the formula if the charges are the same. Now let's try another example. Calcium sulfide. It might be good to have a periodic table in front of you. You can go to Google Images and print one. And you want to have it next to you where you can see what the charges are. Calcium is found in the second column of the periodic table. It's in group 2. And so as an ion, it's going to form a 2+ charge. Sulfide is in group 6A or group 16. And those elements typically form charges of -2. So because the charges are the same, even though the sign is different, these two ions are going to combine in a 1-to-1 ratio. And so it's going to be CaS, calcium sulfide. Let's try one more example. Aluminum nitride. Aluminum is found in group 3A or group 13 of the periodic table. And so it's going to have a +3 charge. Nitrogen is in 5A or group 5A, and it has a -3 charge. So because the two have the same charge magnitude, so to speak, we can write them in a 1-to-1 ratio. It's ALN. Now, what should we do if the magnitude of the charges are different, if it's not the same? So consider the example lithium oxide. Lithium is found in the first column of the periodic table. It's an alkali metal and it has a +1 charge. Oxide is a chalcogen. It's in group 6A, and so it has a -2 charge. So what do we do in this case if the charges are different? You can use a crisscross method, where the charge is going to become a subscript. So the charge on lithium will become the subscript of oxygen, and the charge on oxygen will become the subscript of lithium. And you could ignore any negative charges, because the subscripts will always be positive. So the formula is going to be Li2O1. Now you really don't need to write the 1, so we can simply leave it as Li2O. If there's no number, it's always assumed to be a 1. So that's why we don't need the 1. So this is the formula for lithium oxide. That's what you need to do to write it. So for the sake of practice, let's try another example. Gallium Bromide. So feel free to pause the video and try this example yourself. So what do you think the formula for this compound will be? So let's find the charge on each element. Gallium as an ion is going to form a +3 or 3 plus charge. Bromide is going to have a -1 charge. So using the crisscross method, it's going to be Ga1 Br3. So we could ignore the 1 and leave it as Ga Br3. So that's the formula for gallium bromide. Consider this ionic compound. Magnesium, phosphide. Go ahead and write the formula for this ionic compound. So let's start with magnesium. Magnesium is found in group 2A of the periodic table. It's an alkaline earth metal, and so it has a +2 charge. Phosphide, it's in group 5A, just like nitrogen, and so it's going to have a -3 charge. So using the crisscross method, it's going to be Mg3P2. And so, as you can see, it's not very difficult to write the formulas for ionic compounds. Now, before we move on into examples containing polyatomic ions, you need to know what the polyatomic ions are and their formulas. NO3- is nitrate. That's with an ATE. NO2- is called nitrite with an ITE. So these are polyatomic ions. They're ions that contains many atoms. This is nitride. Nitride is a monoatomic ion. It's an ion consists of one atom. Notice that if it's monatomic, it has the end in IDE. But if you see 8 or I, typically that represents a polyatomic ion. PO4 3-. What is the name of this polyatomic ion? Also, go ahead and name these ones as well. PO4 3- is called phosphate with an ATE. PO3 3- is phosphite. And P3- is phosphide. So P3- contains a single atom, so it's a monoatomic ion, and so it has the end in IDE. Notice that 8 usually has one more oxygen than I. Now, what are the formulas for the following ions? Sulfate, sulfite, and sulfide. Sulfate is SO4 2-. Sulfite, SO3 2-. And sulfide is S 2-. Try these. Let's say if you have perchlorate, chlorate, chlorite, hypochlorite, and finally chloride. What are the formulas for these ions? perchlorate is ClO4 minus. Chlorate is ClO3 minus 1. Chlorite is ClO2 minus 1. And hypochlorite is ClO minus. Chloride doesn't have any oxygen atoms. It's simply Cl with a -1 charge. Now, what are the names for these ions? OH minus. OH minus is known as hydroxide. Cn minus is cyanide. C2H3O2 minus is acetate. This is oxalate. CO3 2 minus is carbonate. HCO3 minus is bicarbonate or hydrogen carbonate. CrO4 2 minus, that's chromate. And this one is dichromate. NH4 plus is ammonium. And MnO4 minus is permanganate. So those are some other ions that you should know as well. So now let's go over some examples. How can we write the formula for potassium sulfate? So potassium is an alkaline metal that has a +1 charge. Sulfate is a polyatomic ion that's SO4 2 minus. You simply need to know that. Unless your teacher is going to give you a polyatomic ion sheet, you need to have this memorized. So now the 1 is going to move to the right, the 2 is going to move to the left. So it's going to be K2SO4 times 1. So we really don't need to write the 1, so we could leave it as K2SO4. So this is the formula for potassium sulfate. Try this one. Strontium phosphate. Strontium is an alkaline earth metal in group 2, and it has a +2 charge. Phosphate, this is something you have to know, it's PO4 3 minus. So the 2 is going to move here, and the 3 is going to go there. So it's going to be Sr3 PO4 2. Whenever you have multiple polyatomic ions, you need to enclose it within a parentheses. Try this one. Barium nitrate. So like strontium, barium is also a group 2 alkaline earth metal. So it's going to have the same charge +2. Nitrate is NO3 minus 1. So using the crisscross method, it's going to be Ba1 NO3 times 2. Whenever you have multiple polyatomic ions, make sure to enclose it within a parentheses. Now we really don't need a 1, so we can simplify it to Ba NO3 2. So that's the formula for barium nitrate. Now let's try some other examples with transition metals. Many transition metals contain variable charges. For example, iron metal can be in the +2 state or the +3 oxidation state. Copper, for example, has 2 common charges, +1 and +2. So when you're given the name of an ionic compound that contains a transition metal, you're going to see a Roman numeral. For example, let's say if we want to write the formula for iron 2 sulfide. The Roman numeral tells you what the charge is. So you need to know what it represents. If you see this, this represents a 1. This symbol represents 2. This represents 3. If you see a V, V represents 5. If you see an I, let's say to the left of the V, that represents 4. Now, if you see the I to the right of the V, you have to add instead of subtract. So it's like 5 plus 1, it's 6. So what do you think this represents? A V with 2 I's on the right. So that's 5 plus 2, that's 7. So you need to know or be familiar with the Roman numeral system. So we have iron 2 sulfide. That means that the iron ion has a plus 2 charge. Sulfide, we know, has a minus 2 charge. Because both of these ions have the same charge magnitude, we can simply write it in a 1-to-1 ratio. It's simply FeS. But even if you were to use the crisscross method, you would get Fe2S2. Notice that both of these numbers are reducible. We can divide both numbers by a common number. So it's going to turn into Fe1S1, which we can write it like this. Try this one. Iron 3 sulfide. So this time, iron has a plus 3 charge instead of a plus 2 charge. And sulfide is the same. So the formula is going to be Fe2S3. So the Roman numeral simply tells you the charge of the element. Let's try another example. Try this one. Copper 2 nitrite. So copper has a plus 2 charge as specified by the Roman numeral. Nitrite, you simply need to know this, it's NO2 with a negative 1 charge. So using the crisscross method, it's going to be Cu1, but we don't need to write the 1, times NO2 with a 2. And so that's the answer for copper 2 nitrate. Here's another one. Copper 1 phosphide. Try that. So copper has a plus 1 charge. Phosphide is PO3 with a negative 3 charge. So this is going to be Cu3 PO3 times 1. Since we have a 1 next to the PO3, we do not need a parentheses for this example. So this is the answer. That's copper 1 phosphide. Try this one. Vanadium 5 dichromate. So vanadium can have an oxidation state of 5. Dichromate is Cr2O7 with a negative 2 charge. So the 5 is going to move to the right, and the 2 is going to move to the left. So it's going to be V2, and then in parentheses, Cr2O7 times 5. So that's vanadium 5 dichromate. Go ahead and try this challenge problem. Lead 4 oxide. This is going to be the last example for today. So lead has a plus 4 charge. Oxide has a negative 2 charge. So using the crisscross method, we're going to see that we're going to have a formula that's Pb2O4. But notice that 2 and 4 are even numbers, which means that we can reduce it by 2. And we should. So if you get a situation like this, make sure you reduce it. If we divide it by 2, we're going to get Pb1O2, which means the final answer is simply Pb02. So if you can, make sure to reduce the subscripts until you get the lowest whole number ratio. And so that is it for this video. Thanks for watching, and have a great day.